Humanoid robots are advancing faster than ever, but most people misunderstand where this progress is actually happening. Despite viral clips and dramatic headlines, humanoid robots are not being deployed randomly into public spaces. Instead, their real progress is happening in controlled environments, places designed specifically to test, refine, and safely scale robotic intelligence. In this video, we'll explore why controlled environments matter, where humanoid robots are being used today, and what this tells us about the future of real-world robotics. Controlled environments include research labs, corporate facilities, warehouses, and private campuses. These spaces allow engineers to carefully manage lighting, layout, obstacles, and human interaction. That control is critical for developing reliable robotic behavior. One major reason robots start here is perception. Humanoid robots rely on cameras, sensors, and AI models to understand the world. In uncontrolled public environments, conditions change constantly. Lighting shifts, people move unpredictably, and objects vary endlessly. In controlled spaces, robots can learn step by step, without unnecessary risk. Another key factor is safety. Even advanced humanoid robots are still learning balance, grip strength, and movement coordination. Controlled environments ensure that if something goes wrong, no one gets hurt and no property is damaged. Safety validation is a major requirement before any broader deployment. We can already see examples of this approach across the industry. In robotics labs, humanoid robots practice walking, lifting, and object manipulation repeatedly under supervision. These tests help engineers refine joint control, energy efficiency, and recovery from small errors. In corporate facilities, robots are being tested for tasks like internal logistics, serving, sorting, or demonstration cooking. These environments are predictable, monitored, and optimized for testing embodied AI systems. Warehouses and industrial sites are another major focus. These spaces are structured, repetitive, and task-driven, making them ideal for early humanoid robot deployment. The goal isn't speed, it's consistency, accuracy, and endurance. What's important to understand is that slow, cautious progress is not a weakness. It's a sign of responsible engineering. Humanoid robots combine mechanical systems, artificial intelligence, perception, and decision-making. Each of these layers must work together flawlessly. Rushing deployment would create more failures, not breakthroughs. Controlled environments also allow robots to learn through repetition. Tasks can be repeated thousands of times with slight variations, helping AI models generalize behavior while staying within safe boundaries. This approach mirrors how many major technologies evolved. Self-driving cars, industrial robots, and even aviation systems all matured in controlled conditions before wider adoption. So when you see a humanoid robot operating smoothly in a lab or company facility, you're not seeing a limitation. You're seeing the foundation of future reliability. Public deployment will come later. Once systems prove they can handle unpredictability, long-term operation, and human coexistence safely. For now, controlled environments are where real progress is happening quietly and methodically. And that's exactly how transformative technologies are built. If you found this breakdown useful, consider subscribing to the channel for clear, unbiased coverage of humanoid robots and real-world AI development. Thank you for watching, and I'll see you in the next one.